Hi all. Now we are going to solve another question from the university question for the year April 2018 compiler design subject. The question is for a given source language statement a equal to b star c minus 2 where a, b, c are float variables. Here it is given that a, b, c are float variables and the symbol star and minus represents the multiplication and subtraction on the same data type. Show the input and output of each phases of compiler. So as we all know, basically there are 6 different phases. Lexical Analyzer, second one Syntax Analyzer, third one Semantic Analyzer, and fourth one intermediate code generator, and fifth one Chord Optimizer, and sixth one Chord Generator. So we will see different input and output combination for these different 6 phases. So first the source language is given as a equals b star c minus 2. So that is given as the input to the lexical analyzer like this. So this is the lexical analyzer. So as we all know, it is the process of tokenization which is to be carried out during this lexical analyzer. That means tokens will be generated from here. So we can get the output as id1 equals id2 star id3 minus 2, or you can write the combination as id comma 1 then equal to then id comma 2 then star then id comma 3 then minus then 2. So this is the output of the lexical analyzer. So this will be given as the input to the next phase which is known as syntax analyzer. As we all know, syntax analyzer generates a syntax tree. So we will get the output as equal to id1 then minus then multiplication then id2 id3 then 2. Why we are writing we are not writing multiplication here? Because when these two operator comes, this will be evaluated first. That is why we will have drawn the tree like this. So these are the nodes, interior nodes, and these are the leaves. So this is the output of the syntax analyzer. So as we all know, the output of the syntax analyzer is given as the input to the semantic analyzer. So this will be given as the input to the semantic analyzer. So I can draw the figure like this, equal to then id1 then minus then star then 2 then id2 then id3. This will be given as the input to the semantic analyzer. So here, as you know, the role of semantic analyzer, one of the roles is type checking. So it is given as all the data values are all a, b, c in the statements are given as float values, but we all know that 2 is an integer value. So some type conversion to be done. 2 will be converted to integer to float. So into real is a type conversion here we are using. So we can draw the output like this, equal to id1 minus star id2 id3 here int to roll, int to float or int to real, into integer to float. So this is a type conversion. Then into real or into float, into real or into float, then 2 is given. So all these values are now float. All these values are now float. So the result we should obtain will also be a float value. All these values are float. So this type checking is done by the semantic analyzer. This will be given as the input to the next phase, which is intermediate code generator. Intermediate code generator. So as we all know, intermediate code generator will use different temporary variables. So first I can write the int to float of 2. So that is the first conversion, that is given as a temporary variable t1 is used here. Then t2 is taken as id2 into id3. This function will be being performed by this operation and it is loaded, the result is loaded to t2. Then we are doing t3 as t2 minus t1. t3 as this is t1, this is t2. Here the value, the result will be t2 minus t1. So here we will get the value as t2 minus t1. So that is to be loaded to id1. id1 equals t3. So these are the intermediate codes generated for the given statement. This will be given as the input to the chord optimizer. Chord optimizer. So what is the role of chord optimizer? Minimize the number of steps. So here we are rewriting the code like this. t1 equals id1 into id2. First this will be evaluated. So we are rearranging the variables like this. t1 is written as id1 into id2. Then t2 is equal to t1 minus 2.0. Okay, t1 equals t2 equals t1 minus 2.0. Then we are just copying that result into. So here we are just using two temporary variables. So these are the output of the chord optimizer. So now we have to complete the last step. So this code is given as the input to the code generator. That is the last phase. Code generator. That is the last phase. So that will be used to give the output as. First we have to perform this multiplication operator. So for that, this content of id1 to be moved to r1, content of id2 to be moved to r2. Load float value. Suppose I am taking content of id2 in r1. You can take any value here. So here I am just taking content of id2. id2 is loaded to r1. Then id1 value in id1 is loaded to id1 value is loaded to register r2. id1 loaded to r2, id2 loaded to r1. Then I am performing the multiplication operator. Mul f r1 comma r2. Here multiplication is done and the result is loaded to r1. So that value, from that value 2.0 to be subtracted. So sub f r1 comma hash 2.0. Then store the result to id 1. r1 comma id1 comma r1, because the translation is movement of content from the register 1 r1 to id1 is to be taken place. So we can write the output as, or the final compiled code for the given statement a equal to b star c minus 2 will be produced like this. Hope it is clear. So we can write as a consolidated form of all this like this. So the first statement a equals b star c minus 2, that is given as the input to lexical analyzer. The output will be tokens id comma 1 equals id comma 2 star id comma 3 minus 2. That will be given as the input to syntax analyzer. It will produce syntax tree like this, equal to id1 minus multiplication 2 id2 then id3. That will be given as the input to the semantic analyzer. The only change is that id1 minus star id2 then id3. The only change is that here int to float or int to real will be taken place, then 2. So that will be given as the input to, this will be given as the input to the intermediate code generator. From that we will get the output as t1 equals int to float of 2, t2 equals id2 star id3, t3 equals t2 minus t1, id1 equals t3. Then Chord Optimizer. So here the number of statements will be minimized by minimizing the number of temporary variables. id1 equals t2. So that will be given as the output to the input to the code generator, and its output will be ld load float r1 comma id2, load float r2 comma id1, mul f r1 comma r2, sub f r1 comma hash 2.0, store f id1 comma. So this is the final output or the final answer of the question we have been given. Hope it is clear to everyone. Thank you.